Every day, thousands of planes fill the skies. Most of them pass within miles or even hundreds of meters of each other, without ever seeing one another. So how is it that they don't collide in such a crowded sky? How is disaster avoided? This is declassified air. Let's dive into the hidden system of the skies. The sky is not empty. The sky may look wide open, but it's full of invisible traffic. Every aircraft follows a strict route, altitude, and speed. And all of this is monitored in real time from the ground. Just like cars on a highway, planes fly in designated lanes. Pilots have to fill out flight plan before flight. According to International Civil Aviation Organization, a flight plan can be filed up to 5 days to at least 60 minutes before the estimated time of departure and delivered to the relevant ATC air traffic control units. But there may be some special cases, for example, in busy airspaces, international routes, or security-sensitive areas. Earlier filing may be required. For emergency or local VFR flights, shorter lead times may be allowed through direct coordination with the control tower or local ATC. By this way, aircrafts are separated by altitude, direction, and distance. Aircraft almost never fly toward each other at the same height. That was the planning phase during the execution of flights. There are some navigational error limits for aircrafts. For example, on the airways for GPS-based navigation errors usually must be within plus or minus 4 nm laterally for high-altitude airways, which is jet routes. In lower altitude and route airspace, lateral navigation accuracy is plus or minus 5 nautical miles for 95% of the flight time. It is called RNAV5 area navigation. In terminal airspace and approaches, lateral navigation accuracy plus or minus 1 nm for 95% of flight time. It is called RNAV1 for conventional navigation, which is conducted according to ground-based navigation transmitters such as NDB, DME, and TCAS, etc. Navigation errors usually must be within plus or minus 4 nm laterally for high-altitude airways, which is called jet routes. For low-altitude airways, lateral navigation error is typically allowed within plus or minus 5 nm. A vertical navigation error occurs when an aircraft deviates from its assigned altitude by more than the allowed tolerance. This can be climbing too high, descending too low, or not leveling off at the cleared altitude. A small error can cause a loss of separation, leading to a potential mid-air collision. Most errors happen in RVSM aerospace, where aircraft are only separated by 1,000 feet vertically between flight level 290 and flight level 410. An example, if one aircraft is at FL 350 and another at FL 360, even a 300 feet error is serious. So that there are some RVSM compliance checks. Aircraft must be certified and maintained to stay within tight vertical tolerances. These are typically Minto primary altimeters, one autopilot, one transponder, one altitude alert system, and, in case of navigational error which is intentionally or not, air traffic control units takes place to prevent mid-air collisions. Controllers track every plane on radar and issue real-time instructions. They tell pilots when to climb, descend, slow down, or change course. Pilots must obey these instructions. Otherwise, military fighter jets can execute intercept missions, which is going to be unveiled in next video. But now let's continue to our subject, the tech inside the plane. But it's not just humans keeping planes apart. Technology does it too. Modern aircraft are equipped with something called TCAS, Traffic Collision Avoidance System. According to the ICAO, all turbine engine airplanes of max, certificated takeoff mass in excess of 5,700 kilograms or authorized to carry more than 19 passengers shall be equipped with an airborne collision avoidance system. If two aircrafts get dangerously close, TCAS steps in. It automatically warns pilots, climb, descend, turn. Both planes are guided away from danger without needing tower input. TCAS system constantly sends interrogation signals to nearby aircraft, receives replies from other aircrafts, transponders, measures range, altitude, bearing, and closure rate, builds a 3D map of nearby traffic within approximately 40 nautical miles, their range, bearing, and altitude. A traffic advisory is generated when the other airplane is approximately 40 seconds from the point of closest approach. If the other airplane continues to close, a resolution advisory is generated when the other airplane is approximately 25 seconds from the point of closest approach. The RA provides oral warning and guidance as well as maneuver guidance to maintain or increase separation from the traffic. If altitude data from the traffic aircraft's transponder is not available, no RA can be provided. Symbols are revised as the TCAS system constantly re-evaluates the motion of vertical motion. Information is indicated by an arrow depicting a climb or descent. If a change of greater than 500 feet per minute is detected, this table identifies the possible call-offs associated with RAS and the vertical restrictions or maneuver recommended in each case. The sky is layered, literally. Different types of aircraft fly at different altitudes. Small private planes stay low, while commercial jets cruise high. Each layer is carefully managed to eliminate collision risk. Planes don't fly randomly through the sky. Each one follows a carefully calculated path. Technology, coordination, and discipline keep the skies safe. You've been watching Skydeck. One more secret, declassified. Like the video, subscribe for more, and let us know your thoughts in the comments. Until next time, keep your eyes on the sky.